Just can't resist, can you? All right, here we go. Let's finish up for these guys. Okay, so we were finding the vertical height after 1.8 seconds. Okay, so am I using the 32 or the 9.8 for gravity here? 32 because this is measured in feet. So 1/2 of 32 will be 16 t squared, and that initial height was 6.5. Okay, I think I got everything in there. Eight times 110. Really, if we want it more accurate, we should probably use some decimals after that 15. Uh-oh. I think I typed something wrong, don't y'all? Because I got a negative. It went underground. Let's see what I did. If y'all see my mistake, let me know. 1.8, 110, sine 15. Oh, I didn't close off that. There we go. Minus 16 times 1.8 squared. Okay. There we go. Oh, do y'all like that answer? I guess it's on the way back down, which would make sense. So 5.9 feet.
Isn't it 15.3?
Did y'all get 15.3?
No, like the angle, 15.3.
Oh, yeah, and we should have used a decimal. That's why I said if I really want it accurate, I should add those decimals in, and even more than the 0.3. So what height did you get using 0.3?
6.9.
Wow, that's a big difference. Okay, we'll say we used 0.3. Go with 6. That's a huge difference. I will follow your work. So if it is set up correctly, it'll be good. You know what I'm saying? Like if you didn't use the 0.3 and you got 5.9, then it's correct as long as I can see how you worked it. Because then I can see, oh, it's just a rounding difference. Okay, 7 feet. Okay, how come? He was jumping, wasn't he? Well, I guess if you're 6 feet tall, yeah, you're already at 7 when you raise your arm or really stretch it out. Okay. All right, last problem. A projectile is fired from the top of a 24-meter tall building at an angle of elevation of 28 degrees with an initial speed of 55 meters per second. Okay, so we're in meters. All right, so picture. We are 24 meters up, and we are firing a projectile, and that angle is 28 degrees. Initial height, 24, theta, 28, initial velocity, 55. That is in meters per second. Okay, I think we got everything there. So when we use our G value, then that will be the 9.8, since it's in meters. Okay, what is the maximum vertical height reached by the projectile? It starts at 24. And if it's being fired at an angle of 28, then it's going to go more than 24, right? Okay, so I'm looking for y, correct? Okay, think about this. I ran out of room, but isn't that a parabola? A parabolic shape?
Just like find the distance it went, and then like in the middle, the height at the middle would be the
Okay, in the middle, what do we call that point? The vertex. Okay, and then the focus would be right below it. I'll give you points for that. Okay, so you've got the vertex right here. Okay, I don't know if you remember this, but in algebra, there's a formula we use to find the x-coordinate of the vertex. And it's negative b over 2a. Does that ring a bell? Okay, so we're going to say the x-coordinate of vertex, negative b over 2a. All right, so that b and a come from a quadratic equation. But once I write my y equals equation, that is quadratic. So I'm going to write my vertical equation, pick out the b and the a, find where the vertex is, which will tell me when it's at its height, and then I'll plug that time into the height equation. Now follow that? I'll go through it again. Once I do it, I'll kind of recap. Okay, so right now I'm just writing the equation for y. All right, so that is time, which that's what I'm going to be solving for. Initial velocity 55, sine theta, which is 28, minus 1/2 times 9.8, which is our 4.9, t squared, plus initial height, which is 24. Okay. I'm going to rearrange it because I like it to be in descending order. Negative 4.9 t squared plus 55 sine 28 t plus 24. Okay, so that's my height equation. That is quadratic. It's a downward facing parabola. I need to know where the vertex is. So I'm going to use that little shortcut to figure out the x-coordinate, negative b over 2a. So that's really my t value instead of x. So negative b over 2a. Negative 55 sine 28 over 2 times negative 4.9, which we know is negative 9.8. 2.635. I'll try to be more accurate on this one. 2.635 seconds. Okay, so after 2.635 seconds, this object is at its highest point. Well, what is that highest value? Well, so I'm going to take this t value and plug it back into the y equation. Okay, so this is going here and here. Negative 4.9 t squared .02. Did y'all get the same thing? And that is meters. So 58 meters is the maximum height. So we basically found the whole coordinate of the vertex, really. We figured out the x-coordinate of the vertex, and then we plugged it into the equation to find the y. Any questions on part A? Okay, find the horizontal distance traveled by the projectile at the time it reached its maximum height. Okay, so we know the height of the time now, and we're just going to sub that into our horizontal equation. So x equals t times v sub 0 cosine theta, that's the formula. X equals time 2.635. Initial velocity 55. Cosine angle 28. And let's type that in. About 128 meters. Good. All right. Okay. Last question. If the projectile is fired towards a taller building that is 300 meters away, will the projectile hit the building? If not, how far from the building will it land? Okay, so what is it we need to know?
The total time and total distance it went.
Okay, and so we're going to have to find time first, right? Just like up here, we had to find time first, and then we found the distance. Okay, so yeah, it's kind of a repeat of what we did up here. So I've got to figure out when this projectile is back on the ground, which means a height of 0. Okay, so find t when y is 0. So that's what we're going to do. Okay, so we're going to say 0 in the place of y equals time, which I don't know, times initial velocity, sine 28 degrees, minus, this one was meters, so it's 4.9, t squared plus 24. Oh, you know what? I already had it rearranged up here. I don't know why I rewrote that. Got it right up here. Oh well. Negative 4.9 t squared plus 55 sine 28 times t plus 24. Okay, so we're going to have to use quadratic formula again. Negative b plus or minus square root of b squared minus 4ac all over 2a. Let's see if we can all type it through our calculator right this time. Now I'll probably get it wrong. Negative b plus or minus the square root of b squared minus 4a. Oops, I don't know why I changed that height to 25 there. It should be 24. Okay, challenge accepted. Let's see. Negative 0.8 seconds. That's not going to happen, is it? That's kind of meaningless. So now I need to go back and change the plus to a minus. .08 seconds. Are we getting those answers? Okay. And then finally, did it go 300 meters horizontally? Because if it did, it hit the building. If it didn't, it missed it. So I want to find x at this time. So the horizontal distance equals the time times the initial velocity times cosine of the angle. And let's see how far it went horizontally. Oh. I don't know if we wanted to hit the building or not, but it looks like we missed it. Okay, so will it hit the building? No. If not, how far from the building will it land? How would I find that? Subtract that from the 300 meters, and it's about 4.7 meters away. From the building. Question. All right.